All right, so we've got the basic foundations hopefully set up. Again, the goal of this algorithm is to find durable change in a time series record, and we use Landsat, although we can talk about later the fact that you don't actually, it just is a bunch of numbers to the algorithm. It doesn't really matter, but we use Landsat because of the depth of the record. And our goal with the algorithm is to find vertices, or another word I'll use sometimes is breakpoints. You think of the trajectories over time, and they're straight lines with breakpoints that separate these straight lines. How do we do that? Okay, so if you go to the chapter of the book, you'll see the path to this visual interface, and I'll get to this in just a second though. But again, we are working with, just in this chapter, we're working with a visual interface, and this is based on my experience trying to help folks learn LandTrender. Launching directly into the scripts usually encourages people to not experiment with the things that really need to be experimented with when you move to your location. So we've built this visual interface to really encourage you to find the best solution. With the flexibility of this algorithm, as I said, comes a responsibility to try and figure out the best solution for your location. And this interface makes it pretty easy, I think, to do that. So that's what we focus on in this chapter. But once you're familiar with this, we do have a lot of other resources that are based on scripts. We have example scripts, we have libraries, etc. And you can find those on the a training guide that we've got at that link on the bottom, or if you just Google eMapper LandTrender GitHub, you'll find the same thing. And that was all put together initially by Justin Broughton, who many of you may know if you've been working on Earth Engine, is one of the working with the Earth Engine team on sort of outreach and development. Okay, so if you go to the book code repo, this is what you'll see. So you'll just see a very brief commented script that says, here's our guidebook, the LTG guidebook at the top under GitHub. And then the script that we're going to work with is on line 14 there. The data visualization download app. So we have one more step to do than maybe what you're used to for this book. So on your own, if you're walking along with us, the first thing is we need to add that our eMapper Lab public repo to your own interface. So you do that first step. Once you're there, you should see in your list of repos where you're a reader, you should see users eMapper Lab public. And then you'll expand the LT data download and hopefully find the LT data visualization download ... tool. Once you've gotten there, click run and it'll initialize the interface. I will pause for just a second, make sure folks can get a look at this, and then I'm going to move on in about 5 seconds. So if you want to grab that link or get a screenshot quick so that you can follow on the next steps. 3, 2, 1, going on. So when you start it, you should see something like this when you click run. I've kind of resized things because I'm not interested in seeing a bunch of code. It's a little bit cut off here, but what we have here is a multi-panel graphical user interface with a control panel on the left. And this is where we're going to do a lot of the manipulating of things. The map panel, where we see outputs, and the plot panel. Let's see here. A link to the slides. Yes, we can do that. Jeff, can you put a link back to the slides in there so folks can go back and look at this? And okay, so we're going to use that to do what? We have to go back to this basic workflow. We've got build a time series of a spectral index or band, set the parameters, run it, get some vertices. And so really, as I said, the reason we built this GUI interface was because we want to emphasize sort of a sequential approach to running LandTrender in your situation. So the first part to really determine is if you are interested in a certain kind of change, usually people come into this with some goal. can we find and characterize that signal in the Landsat record? Never mind the algorithm itself, just is it even there to be measured? And so this is really the first fundamental question: is the signal change evident in the Landsat spectral record? So we want to play around with that. We want to actually explore that. And then if it is, if we believe it is, if we can make the assessment of the spectral properties by looking at the spatial properties and the context around it, then can the algorithm be tuned? Can it be set up to find that change? Okay, so if you just go to our site and run the generic Landtrender parameters with all of our image collections and our change detection characteristics, it'll work okay, especially if you're looking at forest, probably anywhere in the world, it'll look okay, but I wouldn't recommend it, especially if you live in a part of the world where the seasonality is quite different than in my part of the world. And so this is what we want to explore a little bit. We're going to go back to the interface in a second. I'm going to stop sharing my slides and I'm going to switch over to the interface itself. But when we do this, what we're looking for are two things to find this signal in the Landsat record. One is to choose the season on which we build our image composites. And the second is to choose a spectral index that works to track the change well enough to actually capture what you're looking at. Okay, so bring these things with you when we switch over to the interface here. Choose a season and choose a spectral index. And I'm going to stop sharing this. So I have to switch. We're going to switch to Chrome here. And all right. So I'm going to pause for just a second and make sure that folks have a chance to get things looking like this. So if you've found the script in the app, again, you have to accept that repo, load this LT data visualization download app, and then click run, the run button that we're familiar with in Earth Engine for any of our scripts.